In this video, we are going to be multiplying scientific notation, dividing scientific notation, as well as raising scientific notation to a power. In order to be able to do that, you need to remember your three basic exponential laws, which I'm going to just quickly recap in this video. If you want more information on exponential laws, be sure to check out the exponential laws video on my channel. The first exponential law that we're going to just be recapping is the first exponential law of when we multiply the same base, we add the exponents. So when we multiply the same base, we add the exponents. So for example, I've put some examples there for you. 2 to the power of 3 times 2 to the power of 2 is equal to 2 to the power of 3 plus 2, because we add the exponents, and that's 2 to the power of 5. A to the power of 2 times a to the power of 4 is equal to a to the power of 2 plus 4, a to the power of 6. 3 to the power of 5 times 3 to the power of 10 is equal to 3 to the power of 5 plus 10, which is equal to 3 to the power of 15. And then we can even have our exponents when we work with 2 to the power of x times 2 to the power of y is equal to 2 to the power of x plus y. Obviously, we can't add x plus y together because they're unlike terms, so that's how it would remain. If we think about our second exponential law of dividing the same base, when we divide the same base, we subtract the exponents. 2 to the power of 3 divided by 2 to the power of 2 is equal to 2 to the power of 3 minus 2, which is 2 to the power of 1. Remember, obviously, you don't have to put in the middle step. I'm just putting in the middle step for you here. If we have a to the power of 4 over a to the power of 2, remember that that still means a to the power of 4 divided by a to the power of 2. So that means that we'd have a to the power of 4 minus 2, which is a squared. Remember, a can't be 0 because a is in the denominator. If we have x to the power of 6 divided by x to the power of 10, that gives me x to the power of 6 minus 10, which is x to the power of negative 4. Remember, we can't leave our exponent as a negative, so we're going to just flip that and have 1 over x to the power of 4. Our third and final rule that we're going to be covering in this video is raising a power to a power. Now remember, when you raise a power to a power, you're going to multiply those powers together. So if we have 2 squared, and that is all cubed, then that means it will be 2 to the power of, the exponents are 2 and 3, 2 times 3, which is 6, not 2 plus 3. A to the power of 10 raised to the power of 4 is equal to a to the power of 10 times 4, which is equal to a to the power of 40. Alright, so we're just going to carry on with some standard form or scientific notation. If I have 2 times 10 to the power of 6 multiplied with 3 times 10 to the power of 5. I'm going to start by identifying the 2 and the 3, and that's what I'm going to start by multiplying. I'm going to say 2 times 3 is 6. That's going to be times 10 to the power of. Now, if I look at the 10 to the power of, can you see that I'm multiplying the same base, which means that I would then add those exponents. I would add the 6 and the 5, and 6 and 5 is 11. So I would have 6 times 10 to the power of 11. If I have 4 times 10 to the power of 10 multiplied with 2 times 10 to the power of 7. Again, I'm going to start with my 2 and my 4, and I'm going to multiply those together, and 4 times 2 is 8. Then I'm multiplying the same base of 10, so it's 10 to the 10 times 10 to the 7, which is actually 10 to the 10 plus 7, so it's times 10 to the power of 10 plus 7, which is 17. Now what happens if we have a different value created? So for example, I have 6 times 10 to the 18 multiplied with 4 times 10 to the 12. I'm going to start with the process again, and I'm going to say 6 times 4. And 6 times 4 is 24. Then I'm going to multiply the base of 10. So I have 10 to the 18 times 10 to the 12, which is actually times 10 to the power of 18 plus 12, which is times 10 to the power of 30. All right, but now when you look at this answer, you can see that I have 24 times 10 to the power of 30, and I can't have 24 because that's two significant places, and I need only one. So that's going to bring me to a little side note over here for you. If I had the number 24, and I were to say that that was a big number, okay? If I were to write that as scientific notation, do you agree that I could say, well, there's the decimal place, and I want one significant place before the comma, so I would move the comma to there, which means that if I were to write this out as scientific notation, I would have 2 times 4 times 10 to the power of, times 10 to the power of what? Well, it's going to take one jump to get there, so it'll be times 10 to the power of 1. So to take 24 and make it 2.4, I've then times it by 10 to the power of 1, which means that I have decreased the number, so I've created a decimal, but I've increased the exponent of the 10 by 1, which means that over here, I could then say this could be 2.4 times 10 to the power of, it was 30, now I'm going to increase that by 1, times 10 to the power of 31. All right, 7 times 10 to the power of 6 multiplied with 8 times 10 to the power of negative 15. Now I'm bringing in some negative exponents as well. I'm going to start the process in the exact same way. So I'm going to start by multiplying the numbers together. 7 times 8 is 56. Times 10 to the power of. Now I'm going to add the exponents together, but I have a 6 and I have a negative 15. So 6 plus minus 15 is actually the same as saying 6 minus 15, and 6 minus 15 is negative 9. So now I have 56 times 10 to the power of negative 9. But I can't have 56 because 56 is two significant places. So that means I need to change it to one significant place. So I'll have 5.6 times 10 to the power of. Now I need to increase that negative 9 by 1. But because it's a negative number, just don't forget you're going the other way. Increasing negative 9 by 1 becomes negative 8 and not negative 10. Let's do a division question. If I have 8 times 10 to the power of 10 divided by 4 times 10 to the power of 6. I'm going to start and 8 divided by 4. So the process is still the same. We're still going to start with our numbers, except now we're just going to keep in mind that we're dividing and not multiplying. 8 divided by 4 is 2. Multiplied by 10. Now I'm dividing 10 to the 10 by 10 to the 6. And when I divide the same base, I subtract the exponents. 10 minus 6 is 4. So I have 2 times 10 to the power of 4. So now I have 9 times 10 to the negative 12 divided by 3 times 10 to the negative 15. So I'm going to start with my values, and I'm going to say 9 divided by 3, which is 3, times 10 to the power of. Now, when you divide the same base, so when I'm dividing 10 to the negative 12 by 10 to the negative 15, when we divide the same base, we're going to subtract the exponents. So now it will be minus 12 minus minus 15. Now minus 12 minus minus 15 is the same as saying minus 12 plus 15. So minus 12 plus 15 is 3. If I have 2 times 10 to the power of 6 all squared, this exponent on the outside now belongs to the 2 as well as to the 10 to the power of 6. So I'm going to square the 2, and 2 squared is 4 times 10 to the power of 6 times 2, which is 12. Last example, 3 times 10 to the power of 15 all squared. If I have this value here, this exponent of 2, that tells me that this exponent of 2 belongs to the 3 and to the 10 to the 15. So that means that I'm going to start by squaring the 3. 3 squared is 9, times 10 to the power of 15 times 2, which is 30. I hope that this video helped. Stay tuned for more videos.